Our science project is dark matter.
Dark matter cannot be seen. It has no physical form. Most scientists do not know what it is. This is dark matter.
Okay. WIMPs and MACHOs. WIMP is an acronym for weakly interacting massive particles. And MACHO is an acronym for massive rectangular objects. WIMP and MACHO are the two of the most popular dark matter candidates. They represent two very different but reasonable possibilities of what the dominant component of the universe may be. It is well established that somewhere between 90 and 99 of the material in the universe is in some as yet undiscovered form.
Dark matter is a type of matter hypnotized in astronomy and cosmology to account for a large part of the mass that appears to be missing from the universe. Dark matter cannot be seen directly with telescopes. Evidently, it neither emits nor absorbs light or other electromagnetic radiation at any significant level. Instead of existence and radiation at the large-scale structure of the universe. According to the Planck mission team and based on the standard model of cosmology, the total mass energy of the known universe contains 4.9% ordinary matter, 26.8% dark matter, and 68.3% dark energy. Thus, the dark matter is estimated to constitute 84.5% of the total matter in the universe and 26.8% of the total content of the universe.
Okay. Universe, dark energy, one expanding universe. This diagram reveals changes in the rate expansion of the universe since the universe birth 15 billion years ago. The more shallow the curve, the faster the rate expansion. The curve changes noticeably about 7.5 billion years ago. You can see right here. This is the curve. This is the Big Bang. Alright? This would be the farthest supernova. This would be like the present day of our universe. And you can see the acceleration is very quick and the slow expansion in the beginning. See, slowly, faster, as the energy builds up. As the energy builds up, it allows more energy to be expanded, and when the energy expands, it expands the universe as well. And we have a comment from Miss Dunsinger. It was a question
For me,
for Rudy. So I'm gonna read it out loud. Okay. So the question I said two things. I said maybe the cause of the universe expansion is because when the universe expands slowly, it gains more of this energy, and when more of this energy grows, the energy has no physical form, so it cannot be let out. So Ms. Dunsinger's question was, what are the properties of matter and the changes of state? Well, the properties of matter are solids, liquids, and gases, and we know that because a solid is a solid because solid is a rock. It's like a really hard object, and the molecules are packed together. Yeah, packed together and dense, like what Jack said. So, and we know that a liquid is a liquid because the molecules are very spread out and they can move around freely. And we know that a gas is a gas because the molecules are so spread out, it cannot be felt or seen. And kind of like dark matter. some of them can have like steam and sulfur gas, which creates a kind of colorish, yellowish look. So yeah, and the two things I said were, dark energy and dark matter has no physical form because they don't have enough maybe energy or molecules to create a physical form, or it's just that they have too much energy and a physical form cannot withstand all that energy, so it must be let out into different sets of molecules. The question changes of state. Well, Miss Dunsinger told me to pick one of them, and she told the class how helpful pick one was books. Yeah, so we also did some research about this.
All right.
And
All right. She said
that's
Miss
how we
Dunsinger
answered.
and wait. So we'll hand them out.
That's how we answered the question
Right?
how's the molecules spread out.
Yeah.
That's how we answered it. And what do you think is the changes of state? Okay, the changes of state. See, when a liquid, its state when it's a liquid is its molecules are very spread out, they can move around very freely. See, when you put, say, sugar in a cup of water, it turns into water because the molecules slowly expand, spread out more because they can move more freely. And in the air, the gravity pulls them in, but in water, pulls them in, but still lets them freely move around. So that's why whenever you drink your hot cocoa and you put some sugar in, stir it around, sugar's all gone, and you look at the bottom of the cup and there's nothing. Because the molecules have spread out so freely that it has become almost the exact same thing as the liquid it is in. Same thing with gases. When, say, a liquid turns into a gas, the molecules are changed. They are moved around freely. Like, say if you put a hot pot of water and throw them outside, like a hot pot of water and you throw them outside in the cold winter time, all the water will turn into gas because the change of molecules it's so ginormous that the molecules spread out and just disappear.
Okay. Now.
Now we will be back for part 2.